Welcome to this video tutorial on how to program 13110 right rotated bolt hole circle pattern. So, looks like we're going to have to rotate our CAD model around a little bit. I'm just looking at the isometric view here. That is clearly sitting on the bottom face, and that is not the normal orientation that this CAD model comes in at. All right, so we'll have to rotate it right off the bat. Looks like we're doing all of our work on the right face here. I see section view AA here, and I see that section view down here. Looks like we have a +2 minus nothing tolerance we have to worry about. Let's take a look at the datum. So we have datums A, B, and C. So we have our primary is going to be the top plane. Our secondary is going to be this diameter in the center. And then we have datum C is the front surface that we'll use for rotational clocking. And then we'll go through the balloons systematically. So we have diameter 240 plus or minus 10, depth 390 plus or minus 5. No big deal there. One thing I am looking at though is that diameter is 240 thousandths. So if we were to use our standard 3mm probe, well, 3 millimeters times, 3 millimeters divided by 25.4, which is the conversion of millimeters to inches, that gives us 354 thousandths. So I think that might be a little bit too big to fit inside this 240 thousandths hole. So we're going to have to create a new stylus, and at least if I organize this playlist correctly, then there should be a video right before this video that shows you how to build that stylus. And the stylus we'll be using for this is a 1.5 millimeter by 31 millimeter measuring length. So this depth of 390 thousandths is no big deal, plus or minus 5. We'll just probe the bottom of that with a point probably. I see this diameter 1 inch 654 is actually referring to this bolt hole circle right here. All right, so that's referring to the bolt hole circle. I don't see any location for this bolt hole circle, but that location is actually implied by these center marks, and at least the way I read this print, I'm going to the highest level of precision in the title block down here. For 3 place decimal is going to be plus or minus 5. So we'll have to, there's an implied X and Y location we'll have to output for this 1 inch 654, even though the blueprint does not explicitly state that, it implies it. All right, then we have dimension number 4, or balloon number 4 rather, is the 472 plus 2 minus nothing that I referred to before. So that tells you that we're going to want to take quite a few more points than just 3 on that circle, which makes sense because that's an alignment feature anyway. Let's go with the same thing we did last time. We'll go with 7 points on that feature. All right, and then we have 45 degrees right here. That clocks this bolt hole pattern that's controlled by the center mark. That clocks that bolt hole pattern to this bolt hole pattern here. You might ask, how do we know the distance in between this hole and this hole? Well, the center mark is controlling that. And how do we know the distance in between this bolt hole here and this bolt hole here? Well, it says actually up here, we'll get to that in a minute, equally spaced on BHC, which stands for bolt hole circle. All right, so we have, that's funny, I guess I got to check my work a little closer next time. We have another balloon number 5. I'll fix that. We have 4 times diameter 140. Okay, so we definitely need that smaller probe to be able to fit inside that feature there. We're going down to a depth of 630 thousandths rather, and notice that that is commented out. That is in parentheses, so we do not have to output that. That's just giving you a reference for how deep that is in the real world. And to be honest with you, the reason we're not probing this feature here is because it actually is a drilled hole. And calculating the depth of a drilled hole when it has a drill tip at the bottom of it is more difficult than you might think, so we are not going to cover that in this video. All right, and then we have balloons number 6, 7, and 8, which by the time I fix this will be balloons 7, 8, and 9. And those are referring to the counterbore diameter, the counterbore depth, and the equally spaced on bolt hole circle pull-up. So with each one of these holes, 1, 2, 3, 4 on this bolt hole circle, they are implied to be 90 degrees off. So I certainly could have gone in here when I was making the print and made a literal dimension to go from here to here, that's 90 degrees, and from here to here, that's 90 degrees. But you can imagine how that would clutter up the drawing. And it's also cumbersome to try to make drawings like that as well. So in industry, they'll use callouts like this, and that really implies that there are more callouts here. So I think what's going to end up happening is we'll have sub-balloons. For instance, I see a 4 times here, and I see balloon number 5. So really, we should have balloon number 5.1, which is the diameter 140 of this hole here. And we should have balloon number 5.2, which would be the diameter of this hole here. Balloon 5.3 would be diameter of this hole here, 5.4, this one here. So we're calling it balloon 5 here just so the drawing doesn't get cluttered. You can see I've used some pretty big balloons here, so I just don't have room to put all that on there. But oftentimes in industry, you'll see either 5.1, 5.2, 5.3, 5.4, all grouped right here. Or they'll do it the way I'm doing it, where they just have balloon 5, and then in your FAI sheet, you'll have 5.1, 5.2, etc. Same thing goes for this counterbore diameter. This depth, that should be, the counterbore diameter should be 6.1, 6.2, etc., etc. The depth should be 7.1, 7.2, etc. And then the equally spaced on bolt hole circle, that implies that, well, we got our orientational clocking off our center mark for the first one, but after that we have 90 degrees, 90 degrees, and 90 degrees. And notice that that's only 3 90 degrees. We have to stack off of something, so I'm just going counterclockwise here, and however far the end one ends up, if this one's 91 degrees, that one's 91, and that one's 91, well, this one will be 3 degrees further shifted over, so it wouldn't add any value to tell us the dimension in between this angle and, this center mark right here and this center mark here, because if we stacked it all going counterclockwise, we know what the remainder is. No need to double dimension here. All right, so that's what we're doing. Let's go do it. So we'll open up, we'll go to a file, new, and we'll come into CAD and CAD file, load. We'll pick up our standard CAD cube and say open, and then we'll come into planner and measurement plan simulation. To pull down here, set that to base alignment. And we'll turn on our shading, and we'll turn on our base plate of our CMM, and then we'll say fit on the screen. All right, so that's looking good, but we obviously have to reposition this model. Now, before we even open this command, I just want to call your attention to where the base alignment is right now. It is at this corner here, and we are going to be rotating and moving this part all in one command. We really want to make sure that this base alignment does not come with us when we do that. All right, so we'll come over here to our, modify CAD model. Hey, I got it right this time. And we'll click on the positioning tab. First thing, we're going to uncheck base alignment. We do not want this trihedron to come along with us. We'll click on position and center. And I think we just want this face here. And we want that to drop centered on that face, and we'll hit apply. Now notice that our base alignment did not come with us. That is an important point there. Now if we needed to, like for the extra credit, you may want to additionally rotate this about the z-axis at this point. If you wanted to do that, that would be in the transformation tab. We don't require that, so I'm not going to cover that in this video. If you decide to do the extra credit, where this is rotated toward the front, then you'll have that one additional step to do, and you can refer to last week's video on how to do that, and that's why they call it extra credit and not regular credit. All right, so we'll turn off our base plate. We no longer need to see this here, and we're going to start with our base alignment. So actually, backing up a step, we're not going to start with our base alignment because we need to have a special probe to be able to fit inside of these tiny holes here, right? To fit inside of those tiny holes, we're going to need the 1.5 by 31 millimeter stylus. So if you haven't already, go back and watch the video on how to do that. Again, if I did my job right, then that should be at the beginning of this playlist anyway, but we'll do we can't do an automatic stylus system change. That's what you do when you're at stick. we have to do a manual stylus system change because our probe rack is not configured on simulation. So we'll click on that and we'll hit pick up stylus system. It says insert stylus system. You say OK, and you simply select the one you want from the list here. So you should have one that's already been imported called 1.5 by 31 millimeter stylus, and just say OK and then close. So now we have the correct stylus on there, so everything we do in this program will default to this stylus. Of course, we can always overwrite it later, but we won't have a need to do that in this case. So we'll come over to the measurement tab and we'll click on base alignment. We're going to create a new base alignment and say OK. And then we'll hit the pull up, do define select geometry. We're going to select a plane, then we're going to do a circle on cylinder right here. And then we're going to do a line on plane, and that'll be the front plane here. All right, and then we'll say OK. Now, just a quick note, if our tertiary alignment, in this case, the one we're using to orient, also known as our planar rotation in this case, if that were going in the y-axis and we were concerned that we might get close to this boss that's sticking out, just keep in mind, as we said in last week's video, if you're trying to probe this line here, you may have to add some extra clearance data to jump up over it. And the only reason I even mention that is if you're doing the extra credit, the model will be oriented in a different way, and depending on what the blueprint says for alignment, you may have to jump up and over that. So just a helpful hint there. All right, so that's that. Looks like our base alignment is in the correct spot. Looks like our probe is also way out in no man's land there as well. So let's just open this up. Right, so I clicked on the little joystick icon, and that kind of recenters the probe where it wants to be. If I want to be a little bit more deliberate, I'll click on base alignment, and then I'll set the X to 0, the Y to 0, and I'll set the Z to 1 inch. So that way I know exactly where my base alignment is, and the real reason is so that I can hit fit, and now it'll actually fit the model to the screen. So that's a helpful hint. All right, the next thing we want to do is set our clearance plane. So we'll click on clearance plane from model, and the defaults are good, so say OK there. Do I want to update the clearance plane settings? I do not. Now we probably want to go back into our features and make sure that our strategies make sense there. So my strategy for plane defaults to polyline. That's actually not what I want in this case. I want 1, 2, and 3 points, and I'll say OK and OK. And then, whoops, for the circle, let's go into our strategy, and mine defaults to circle path and 3 points. I'm going to change that to 7, and just noting that I am doing single points here, it's a little bit easier to prove out programs when they're single points. Now, if you didn't have the circle path, you could just hit delete and then come up here to circle path and add it in. All right, and the last thing we want is this 2D line, and we're going to come over here to strategy, and mine is doing an auto path. That is actually not what I want. I want 1 point here, and 1 point there will be just fine for what we're doing. So our alignment is now complete. Maybe we want to come in here and grab all these and form a group, and then rename the group and call it align. And let's see what else we need to do in our program. Okay, so we need to basically touch all of the circles. And we also need to touch the depth of the counterbore on only these 4. 1, 2, 3, 4. And I say only because there is a 5th one. The 5th one is datum B, right? That's 472. And for whatever reason on this print, the depth of datum B is not important. And also the drilled hole at the bottom of datum B, also not important. There must be some sort of locating boss that only touches the counterbore here. Who knows what this part goes to, right? However, on all of the other holes, we have to probe the drilled hole at the bottom. We have to probe the counterbore diameter and the counterbore depth. So that means we're going to touch a circle at the bottom, a circle at the top, and then a point at the bottom of that as well. And very similar for the other bolt hole pattern as well. We have 4 times diameter 240, depth 390. So that means we got to touch a circle and a point at the bottom. So it looks like this is really going to be a patterning type feature. So let's see how we can do this much, much easier than by selecting each one individually. by simply using patterns. So next thing I'm going to do is define a circle on cylinder, and I'm going to do a circle there. I'm going to do a circle there, and I'm going to do a circle there. So that way I already have all the circles I need. We're going to need points at the bottom of some of those features, so we'll go define points. Let's put a point right there. Say OK. And then let's also put a point right there. That's kind of funny. Calypso told me I crashed on the way over to that point, which I guess, you know, it did. All right, so we could go and do that for every single one of these features, but that would be a lot of effort to edit if you needed to change something, let's say. Like if you needed to change your strategy or you wanted to directly output characteristics and you wanted that to happen on every one, certainly a pattern would be the right way to go. So on circle 2, which is this circle over here, the one highlighted in pink, we're going to double click, and on options, we're going to hit the pull down, and we're going to say pattern. All right. We'll accept all the defaults here, except we will highlight rotational pattern and say, whoops, I'm sorry, we'll highlight rotational pattern and say OK. All right, now our center in X and Y and Z is going to be 0, and that's kind of nice because our datum is already positioning our X, Y, and Z at 0. So our alignment is already there. If our alignment wasn't there, like let's say our alignment was at this lower left edge here, we could use the X to shift over and the Y to shift up. In this case, that's not necessary. Angular pitch is going to be 90 degrees because these whole patterns are 90 degrees equally spaced. And real number is the total number of features in this pattern. So we have the initial one, the C, that's 1, 2, 3, and then 4 in this case. And we could exclude instances. Let's say we only had, 1, this one was missing, we had 3 and 4. We could put our real number at 4 and we could exclude indexes number 2, right? So a lot of other functionality here. We don't need any of it, so we'll just hit OK. And now our pattern is done, and we see we have 1, 2, 3, and then 4. And the other thing we can do here is go to wireframe and turn our model off. And now we can see, I don't like how the text is white and the model wireframe is white. There's probably a way to change that. I don't know how, but you can see 2, 3, and 4 if you know what you're looking for. Just look for the numbers inside of the teal blue color. All right, and then say OK there. And just for ha-has, just to see if that works, let's grab our simulation and let's slow that down by 1. And let's just grab everything at this point. We'll do a Control A and we'll hit Run out of the Features menu. And we will clear existing results. We'll do our Measurement Plan 1 or whatever your third alignment down is. We'll do Current Selection. We're going to run from Feature List, Clearance Plane, Slow Through First Feature. And then we'll do 55 millimeters per second, and we'll say start. So we get a collision right off the bat because shame on me, I did not. Now what is this one happening for? We're getting all sorts of collisions. Just turn that off for a second. All right, so we got a collision right off the bat because I didn't move to the clearance plane. But right here, this is going to be so painful, especially with this pattern. If you don't turn arc motion off, the simulation just runs very, very slowly here. I'm also noticing that the retract distance seems to be quite large. So this is something we're going to want to go back and edit, especially before we get into these smaller holes, like this hole here and that hole there. So even just from watching the simulation, I can see that that did do the pattern. I can see that we are going to have some retract issues inside of that smaller hole. And I can see that we need to adjust our arc motion mode. So we have our pattern for the first bolt hole circle feature. We just have to do some feature settings editor. And we'll come over here to our travel and our clearance group. We'll do all the standards here. We'll grab our clearance group. And even though it's already all plus Z down here, I'm going to set those all to CP plus Z anyway. It's good practice. Our clearance distance, of course, wants to be set to 0. retract distance for your alignment features, which is going to be, see how align will expand or collapse there? It's actually the align group that I have plus the 3 features that are underneath it want to be set to 250. And then all remaining features, our standard is to do 50 thousandths. Stylus system change clearance plane, we don't need that. Arc motion mode, we want to grab everything here and set that to off. Form related strategy, don't need it. For speed, we don't need it, we can leave that alone. So we'll come down to probing, we don't need to do anything inside of here. Stylus system, if we wanted to double check, we could come into stylus system and make sure that we do have that 1.5 by 31 millimeter throughout everything. And by the way, when I wrote this program the first time, I had the 3 by 50 millimeter for these larger counterbores, and I didn't realize it wouldn't fit inside these other features. And I ended up having to use the feature measurement plan editor features, I guess it's called. I had to use this window to go back and mass edit that, but really, it's not a huge deal to have to do that after the fact. So. All right, so we'll come back over here to our features menu. I like what I see so far. Notice that circle 2 now has 4 elements in it, 4 features because of that pattern. So we'll come in here to circle 3 and let's see what circle 3 is. Circle 3 is this small circle at the bottom of that counterbore. We'll double click on that. We'll hit the pull down and go to pattern. And hey, look at that. We have rotational pattern 1 is already in existence. So we'll just say OK on top of that and OK. And then we can go to wireframe and turn our shading off. And you can see that we now have 1, that's the seed, 2, 3, and then 4. We'll do the same thing for the others. Circle 3 is actually this circle over here. We'll hit the pull down. We'll go to pattern. Our pattern's already here. We say OK and OK. That creates our rotary pattern there. And we'll do exactly the same thing for points number 1 and points number 2. Feature as a contact point or net point may not be suitable. Should this be converted to a plane point? Let's say yes there. Okay. And then same thing for point 2. And we'll switch that to pattern, rotational pattern 1, and yes and OK. All right, so you notice that these turned gray after we did that, and that's because while we do have information about the first of the 4 of these features, we don't have information about the other 3. So I'm going to do a Control A again. I'm going to say run. This time I'm not going to clear existing results because there's no sense in rerunning the whole program, right? We're going to do current selection, but it's only going to do the additional features that we need based on our selection. Right? So in other words, it didn't destroy the point cloud. It left what was already green, green. Or it left, sorry, it left what was already green, green. And anything that's gray, it went and probed those features. Okay, notice how much cleaner the simulation runs when you turn arc motion mode off, especially when you're doing this many holes. You want to do that, save yourself some time. All right. And at the end of all that, we have now verified that our program runs correctly. I guess, yeah, I should turn clearance, or I'm sorry, I should turn collision check on and run it again. It looked like from seeing it visually, it was fine. I'm not going to take the time to do that in this video. So now we're going to output some of these features, or I'm sorry, some of these balloons. So we have balloon number 1 is the diameter 240, but notice this 4 times over here means that we need to do this 4 times. Okay, so how are we going to do that? Well, let's come back over to Calypso here and look at our characteristics menu, and I don't see any characteristics at all, which makes sense because we didn't output any yet. Well, we can come over here to our features tab. We can click on, we'll go find whichever circle that is. Looks like it's circle 4 based on the way that I wrote this program. And let's see what we get if we just output the D on this. And I'm not going to worry about the nominal or the tolerance yet. I'm just going to say OK. And then we come over here and notice that that gives us diameter, and then it says 1, 4, 1. Well, what does that mean? Well, I believe that that is talking about this feature itself. Well, let's run this from the characteristics list. And we'll just say all characteristics. And here, we're going to run this for all characteristics. We're not going to clear existing results. Well, we already have information for this in our point cloud that we got based on running from features list. So by unchecking this, I don't have to run anything. I'm going to run all characteristics. Well, there's only one characteristic. So basically, I'm just saying take the point cloud you have from the features tab, run it through whatever is in this list, and generate a dimension report of everything in this list. And in this case, all that means is take the point cloud from that one circle over there and output it into the dimension report. Okay, now if that happens, what just happened on my screen, nothing popped up, well, you come back here and go to View and Multiple Report. And look at that. I thought it was only the one circle, but it gives us all 4 circles. Now, these nominal values are all coming in as whatever size they are. Of course, I'd have to go back and edit that and the tolerance. I'd have to go back and name these features accordingly. Notice how it gives us the parentheses at the end that says 1, 2, 3, and 4. So those should correspond to balloon number 1.1, 1.2, 1.3, and 1.4. And the same is going to be true for this depth of 390, and you've seen how to do that in other videos. All you have to do is output the Z depth directly of the point that was measured at the bottom of this. And the same goes for this 4 times 140, this 4 times counterbore diameter, and 4 times counterbore depth. So really, the only things that we haven't covered in this video so far is how do we do this bolt hole diameter of 1 inch 654. So again, I'm not going to take the time to populate every single one of these characteristics, but let's go do a a feature. We're going to do a circle. And this is not a measured circle. This is going to be a recall. And recall is going to pull the center point of each of these features. So we're going to recall circle 2, but remember, circle 2 is made out of 4 features. So I'm going to say OK here, and notice that that automatically generates that bolt hole circle pattern, and I can output the diameter directly. Now you might say, hey, that's the diameter of these 4 counterbore holes, not the diameter of these 4 end milled holes, whatever you want to call them, flat bottom holes. Okay, well, we're also going to need another one of these, so we'll copy and paste it. And circle 6 is going to be the same recall. However, this time we're going to recall the other bolt hole pattern. All right, so we're actually going to have 3 of these. And they're not all necessarily going to have the same diameter. All right, we'll copy paste that again. We'll hit recall again, and this time we'll do circle 4. So we had a bolt hole diameter for circles, the counterbore at the top, the drilled hole at the bottom, and then the other bolt hole circle pattern here. And you might say, that seems like a little bit overkill. Well, the thing about inspection is you're not allowed to make any assumptions. If the machinist that was making this, if they know that they spot drill, end mill, and then reamed that hole in the center, and then they circle milled this hole on the outside, yeah, they can make the assumption that this feature is concentric with this feature. But from an inspection standpoint, who knows what happened to this part? Who knows if this part came out non-conforming? The machinist took the part out of the machine, brought it over to inspection. Inspection said, hey, this is no good. You got to go fix it. They put it back in the machine, and now it's not sitting in the exact same spot. And then they remachine this counterbore off location. Well, the bottom line is we have to make sure everything about these callouts satisfies our center marks here. So our center marks are really controlling all of this positioning. And this one diameter 1 inch 654 really applies to all of these because the center marks go directly through the bolt hole circle in each case. Now we also have this one literal 45-degree angle right here that we have to take care of, and that is going to be a line. Well, actually, we already have our y-axis that goes directly through here, controlled by the center mark. So we need to build a line from datum B that intersects specifically this hole here, which I believe is, I'm going to pick the counterbore in this case. I believe that is, this was hole 1, 2, 3, and 4. So that'll be index number 4. So what do I mean by index number 4? Well, you see how on circle 2, which is this guy, it has a 4 next to it. Well, index 4 is the fourth of those 4. Index 4 would be, I don't know if you can see it on the screen here, but index 4 would be this right here. See, the number 4 of this pattern. All right, so we have to come in here and go features, and we want to do a 3D line. We want to double click on that, and we're going to go recall. And we want to recall circle 1, which is datum B. That's our central hole there. And we want to intersect that. Notice we have a pull down here. We want to intersect that, so hold Control, and click on circle 2, index number 4, and then say OK. And notice that that creates the exact line that we wanted. Now in this case, our AZ comes out correctly. We got 45 degrees, but we want to reverse that, right? So we're going to have to toggle around with these buttons. Instead of going X, maybe we want to go X minus here, and then we want to flip our space axis. Okay, if you can't get that to work with X or X minus by toggling this and this in combination, what you might also want to do is just come in and reverse the order that you pick these in. We'll do circle 2 and then circle 1 and see if that gives us the positive 45 degrees that we're looking for. All right, so you may have to toggle this button a little bit. You may have to toggle this button a little bit. There are many combinations you can choose between the two of them. It may be A1, it may be A2. For a constructed feature, we truly don't care which one of them it is. We just need the nominal to match what's on the print. I'm not going to update this here because I can't anyway. I'm not going to update the tolerances either. I'll just say OK. And then we can see that that comes out over here in the characteristics tab, and we can go modify as necessary, change the name, change the nominal, change the upper and lower. I won't spend the time on that for this video. All right, so we have to, I guess, construct another line that goes from here to the center of this feature and the center of that feature and the center of that feature. And then we have to output the 90 degrees in between there. I'll do one of those, and I'll leave you to do the other. Well, one of them will be here. You'll also have to do one here and one here, so I'll leave the other two to you. So in this case, we could recreate the line, or we could just copy and paste it. Let's grab this line here, and now when we do our recall, instead of doing circle 2 and circle 1, or I'm sorry, circle 2 index 4, and circle 1. We'll do circle 2 index 1 and then circle 1. And we'll say OK here. And no matter what we do here, we're not going to be able to get the correct A1 or A2 because we're now rotated off by 45 degrees. So how are we going to take care of that? Well, in this case, we have to have an alignment that is already pointing in the correct direction. So I'm not going to output the tolerance just yet. I'm going to say OK here because I can't output the tolerance because we need to be aligned with wherever this initial line was. All right, well, that means we need to come into Resources, Utilities, and Alignment. We need to double click on that. For our spatial rotation, we have plane 1. For our Z origin, we have plane 1. For our planar rotation, we're going to pick 3D line 1, right? So I'll just click on that so it previews again from the screen. I'm just trying to show you the preview here. The preview is real quick, so yeah, you got to get it quick. Planar rotation is going to be line 1. Say OK. X origin is going to be circle 1. OK. Y origin is going to be circle 1 as well. And notice that the little trihedron preview is showing up and it is oriented how we want. And then we say OK. So we have alignment 1. And you can see all of the affected features. Our x-axis is now aligned with that. Now, once we have that, for our 3D line 2, instead of going to base alignment on this, let's just go to alignment 1 and notice that these numbers for our nominals change completely. So there's our alignment 1. Well, maybe we want to output, instead of negative y, we want to go to positive y. I'm thinking we actually want to switch from y to x. We want to change where we're referencing on this. Aha! And there is the 90 degrees that we're looking for. All right, so that's how you do it. If these are all 90 degrees equally spaced, so you got 90 from here to here, once you find out where this one is, you have 90 from here to here as well. So you need to build another line, have another alignment, output its orientation, angle really. Then you have to align to this one, build another line, output that angle. And I know that's painful. There may be an easier way of doing it, but hey, I don't know what it is. So this is the way we're doing this one. It'll be good practice. So you might also be wondering, hey, how are we going to output the angular position of these 4 holes that follow the plus sign pattern? The ones, you know, this one, this one, this one, and this one. How are we going to output that? Do we have to build alignments for that? And the answer with that one is no, we do not have to build alignments, because that one has center marks that go directly through it that are orthogonal. By orthogonal, I mean they're already at 90 degrees. They all already follow the Cartesian coordinate system. So when we output the angle of these, yes, we do need to construct lines to find out what the orientation is. However, once we construct the line, we can simply output its angle directly based on the Cartesian coordinate system. And yes, you will have to come in. You will have to come in here when you output your angle A1 or A2, and you may have to toggle this. You may have to toggle that. You may have to reverse the order of the recall when you create the line. But you should be able to get all of those in at 90 degrees on their nominal without having to build any additional lines, at least for this pattern. So this pattern being rotated off at 45 degrees, man, that one was a pain, but it is what it is. All right, so I'm not going to take the time to do all that in this video. You can play around with that on your own. And that's all I got for you today. Thanks for watching. I'll see you at the next video.